Okay, so 8.6 is about um, parabolas in vertex form. So we're talking about quadratic equations, specifically quadratic functions. And those quadratic functions, when they're graphed, are called parabolas. And so there's going to be some different forms that we're going to talk about on this. And so first off, I want to just try and give you what it looks like what vertex form looks like. So here's like the form of it. So in vertex form, it looks like this: y equals, let's see here. Actually, let me put this in. So I'm going to make some of these things a few different colors, just so when I refer to them, it will be easier to kind of see what I'm talking about. Let's see, so this is saying y equals a times x minus h all squared. So that squared part is telling us that it's a parabola. That's the shape of it. And then plus k. All right, so this a, h, and k do something specific to the parabola, and they're changing them in different ways. And so this a actually does a lot of different things. So that number out in front is, if this is a negative number, then that means it's going to be an upside down parabola. Okay, so I'm just going to draw some things here. So if it's negative, then it is an upside down parabola. All right, if it's positive, it means it's right side up. All right, and then, but there's some things that are a little bit specific when it is positive or negative that you need to know about. So if the number is greater than 1, right? So if it is, even if it's like 1.1 or 2 or 10 or anything like that. So if it's greater than 1, that means that it is getting skinnier. All right, so it's like really steep. It's going up a lot faster than it's going out. And if it's less than 1, oh, sorry, I didn't mean less than 1. That's not, I meant between 0 and 1. Then that means it's going to be a wide parabola. Okay, so those are just kind of different things that A is doing to it. Now this H right here is what's moving it left or right. So if it is positive, if H is a positive number, then it's moving it to the left. So I'm gonna, let's see, I'll put down here. So positive number, it moves it left. And if it's a negative number, that means it's moving it right. And so sometimes people think, gosh, that seems kind of backwards, right? Because when we think about, and when we do some graphing, I'll kind of show you what I mean. But it's because these, like when these parentheses are around it, it's like doing kind of the opposite of what you're thinking it's going to do, because you're trying to figure out what value of x would make that 0. And so that's why it ends up moving in these directions. And then this k is moving it either up or down. So if it's positive, it's a positive number, it moves it up. And if it's a negative number, it's moving the whole parabola down. Okay. So that's just a little bit about what the different parts of the parabola are doing. And that's going to make it a lot easier to be able to kind of deal with some of these. So let's do a few examples here where we look at some of these. So let's say that I have something that looks like this. So if I have y equals x minus 2 all squared, and then minus 3. So when I'm looking at this, I can tell, remember we said that this is going to be in vertex form. So that means it's really easy to pick out what the vertex is. Okay, and so the vertex is found using those two numbers there, that 2 and that negative 3. And so with the stuff that's inside the parentheses, right, you're doing kind of like the opposite. It's not negative 2, but our x value for our vertex is going to be a positive 2. And then our y coordinate in that stays the same. That is going to be a negative 3. So I tell students to think about, like, so if something's inside parentheses like this or any kind of grouping symbols, I tell them to think of this little statement that says insiders are liars. And that just means like they're kind of doing the opposite of what you think, right? So even though this says x minus 2, our x coordinate here on our vertex is a positive 2. It's like the opposite of what that is. Where the stuff on the outside, when it's not inside parentheses, it just stays the same. Okay, so then also so besides understanding what the vertex is, I also will want you to know how those things are moving it. And so remember that the number that is inside here, that's like this h that we had over here. And so since it is an x minus 2, right, and so when I'm dealing with that, right, when there's like a negative number there, right, when it's a minus there, then that's moving it right 2 places. Okay, so moves right 2 places. And then that negative 3 also is telling us that it's going to be moving down 3 places.
And what happened with the x?
This x right here?
Yes.
So remember, in any kind of a formula, you always need an x and a y, right? Remember when you did like stuff before with just linear ones, if you had like y equals 2x plus 1, right? That x is just when we're figuring out like values to be able to write it, we're going to pick those x values and we would put them in place of x, but they could be a number of different things, right? Actually, an infinite amount of different x's that you could pick. And then when you pick those and put those in, then you could figure out what that y value would be for it. So look at like what we did here. So say that, we let x be positive 2. All right, and if I put that inside there, let me write it over here. So if I have y equals parenthesis 2 is what I'm putting in place of that, right? So 2 minus 2 squared, and then minus 3. Well, 2 minus 2 is 0, 0 squared is still 0, so I have y equals 0 minus 3, and 0 minus 3 is just -3. So when I put 2 into the function, I get -3 out. All right, so that is a point on the graph, and that point is a very specific point that we need to know. It's the vertex. Now, the vertex means the turnaround point of a parabola. And so I'm going to also graph this over here too. So it might ask you to write in words how things are moving, what it's doing, going left or right, up or down, if it's getting skinny or wide. But then they also ask you to graph it, right? So we have one point, the vertex. So over 2 and then down 3 is right here. And we know that the number that's in front of this isn't written there, but if there's nothing there, it's like that A is a 1, okay? And so it's positive, so that means we know it's going to be a right side up parabola, because when it's negative, it's upside down. When it's positive, it's right side up. And I can put that on there, but that's just the way it's going to go. But now let's put just a couple of different points in there so we can see what the rest of this is going to look like, right? So maybe let's put in points just, to the left and to the right of that vertex so we can see what's happening there. So let's put in a +1 for x, and let's put in a 3 for x. Okay, because I'm just trying to see what's happening, like what the shape of this is looking like. So if I put 1, right, again, I'm putting it right here in place of x. So I'll do this kind of over here. So I have y equals 1 this time. So I'm putting in place of x minus 2 all squared, and then subtract 3. So 1 minus 2 is -1 all squared minus 3. Well, -1 times -1 is actually a +1, right? So this is really saying 1 minus 3, which is -2. So when I put x or 1 in for x, I get -2 out for y. So that point would be over 1 and down 2, so about here. Okay, and then I can do the same thing here, put 3 back in there. So y equals 3 minus 2 all squared minus 3, right? Because again, I'm putting that x value in here. So 3 minus 2 is 1, and then 1 squared minus 3. 1 squared is just 1. So we still get y equals -2. So now I'm going to the right 3 and down 2. And so I can kind of see the shape starting here. And parabolas are always going to be kind of a U shape. So they'll either be a right side up U shape, or they'll be an upside down U shape. And so that's what parabolas always look like. Okay, and so I can kind of see that shape taking place here. So it's, oops, harder to draw on here sometimes. Oh my goodness. So it's going up like this, and then going around kind of like that. Okay, so something like that is what that's looking like. Okay. What questions do you have on that? On the graphing of it, or finding those points, finding the vertex? Anything there I can clarify better?
For the parabola in vertex form, it's gonna be always that form.
Yep.
If I have more numbers inside of the parentheses, that's going to happen?
So there's not
But
going to be anything else inside the parentheses besides whatever h is. There will only be a number there. So when
it's
it's,
one number.
yeah. So there could be a number here in place of the a number here in place of the h, or a number here in place of the k. Those are where our numbers are.
Can you
So,
please another example?
yeah, yeah, we'll do another example. Okay, so let's look at something like this. So this time, if we have, so y equals 2 times x minus 1 all squared plus 3. Okay, so looking at this, what would our vertex be? Kind of put a
It's the opposite of the things inside of the parentheses, right?
Okay,
It's
so the,
1, 3.
Yep, 1, 3 is our vertex. Awesome. Okay, and so this is telling us, so let's point out what each of these things mean here, right? So this 2 is telling us that it's right side up and skinnier. Okay, so I'm going to put right side up. All right, so it's going to look kind of like a U shape like this, and skinny. Okay, and as that number gets bigger and bigger, like if that was a 10 instead of a 2, it would be like really, really skinny. It gets skinnier and skinnier as that number gets bigger and bigger.
If what number is gonna be more skinny? If it's a 10?
If it's bigger number, it's even skinny. Yep, more skinny. Yep.
Okay.
Yep. Okay, and then this number here is telling us it's going to move where?
Down.
Look again.
Oh, so it's minus 1, right?
Mm-hmm. Yeah, this part.
Oh, I take the 1 of the vertex.
Yeah, so it's not moving down, it's moving right one place. So the stuff inside the parentheses is telling you whether it's moving left or right.
Okay.
Okay. That's okay. That's why I was just asking, because I want to make sure it's clear. Okay, so it moves right one place.
And how can I know if it's right or left? Oh, sorry, it's upstairs. Sorry. Never mind. Forget my question.
That's okay. Yeah, no, if it's negative inside here, like if that's a minus sign, it's moving right. If it was a plus sign, it's moving left. Okay.
Okay.
And then this 3 is moving our parabola how?
Moves up.
Yep. So it's going up 3 places. Okay, so let me come back to this last one here, just because I want to make sure it's really clear. So if we had the function just y equals x squared, okay, this is just a standard, just parabola shape where it doesn't have any moves going on with it. And that looks like this. It starts at the origin, 0, 0, and it goes up from there. Okay, so this is kind of what we're comparing everything to. So this is what it looks like, but do you see, like from here, we said it's moving right 2 places. So if we went right 2 places, we'd be there. And then down 3 places. And that's what takes us right here to that new vertex. So it's that, so that whole thing is moving right 2 places and down 3 places. And that's what our vertex is telling us. How far from, the origin, that 0, 0 point is it? And so that's what I'm talking about when I'm talking about these different things here, is how is it different from this y equals x squared graph?
Okay. And is we take that example, the first parabola in the when the vertex is 0, 0, is when we took another example and we comparing with that one?
Yeah, so it's always, so when I'm saying like it moves right 2 places, I'm saying the regular one, it's called a parent function because it's like it looks like it, but it's always at 0, 0. And so this one that I have in red here is just kind of the standard form where it's not moving at all. But this one's saying, okay, from here, I'm going to go right 2 places and then down 3 places. And that gives me my new vertex right there at that 2, -3. So these things that I have written there, right 2 places, down 3 is telling us where that new vertex is at. Okay, so if we have, so let's look at this again. So let's say I have that, that standard parabola shape, like something like this. Okay, so it starts off there, all right, but where is it being shifted then from there on this graph? Like, so if we're trying to graph this, how is that being shifted?
2 spaces.
And so we haven't talked about the 2 yet. What about, so how is it moving to the left? How is it moving to the right? So how are we moving this point? Just like we did on this one up here.
Oh, trying another points? Like, when you calculate that? Or is it just with the formula we look how to move it?
Yeah, but we can look here, right, to see how it's being moved. The vertex is kind of telling us how it's being moved. And then, then we can find some other points too. But if we look to see, so we're saying, okay, it started there at 0, 0, but instead of my x being at 0, it's going to move over 1 place. All right, but then that's not all. It's also going to go up 3 places from there. So I'll go over 1 and up 3. And so now that's where my new vertex is at. Does that make sense? Because that's what this point is telling me, but it's also saying, okay, I'm going to go to the right one because of this, and then up 3 because of that number. Okay. But then we haven't used that 2 yet at all, right? That's telling us that it's going to be skinnier, but how much skinnier, right? So let's go ahead and put in like some numbers, right? Pick some x's and figure out the y's so we can see what other points we might have here. And again, like going, on either side of that vertex would be a good idea. So you want to choose x values, like we have our x value as 1 right now. So let's choose 0 and let's choose 2. All right, and then if you need to, you can choose more than those, but you should at least, like when you're drawing it out like this, you should have at least 3 points. So we already have 1 here, 1 point there, right? So now we're going to make 2 other points. Okay, so what am I going to do with this 0?
Replace.
Yep, so we'll just go to that there. So I have y equals 2 times 0 minus 1 all squared plus 3. And then let's just simplify this. So 0 minus 1 is negative 1. So I have 2 times negative 1 squared plus 3. Oops, that looks like a z, but that's a 2. And then again, make sure you're doing order of operations, right? You got to do the exponent first. So negative 1 squared, yeah, is just going to be 1, right? So we're doing 2 times 1 plus 3. Now we got to do multiplication before we do addition. So 2 times 1 is 2, plus 3 is going to give us 5. So that's going to be a point here. Let's see. So over 0 up 5 is about there. And then if we do another one, all right, so let's put 2 now in place of our x. And then just simplify that. And we still come out with y equals 5. So now over 2 up 5 is going to be about here. And so it might be kind of hard to tell on my picture, just because my pictures aren't the best, my graphs. But if you were like to graph it, like when you go and do the algebra assignment, you'll be able to see a little bit easier that when this number is bigger, like it is getting, it is skinnier than the regular one here. I mean, this one, you can kind of tell a little bit, it's a little bit skinnier, but yeah. But when you're graphing it on that thing, it'll be a little bit easier to tell. Okay, questions on that?
No.
Okay.
So, yeah, I'm just trying to remind with the 2, if I have three options. The skinny between 0 and 1 is white, and negative is upside down, like the opposite, like the parabola looking to the other side, right?
Yep. Okay. So we're going to do one more. We're not going to graph this one, but on this one, let's just tell we'll say what the vertex is and how how it's moving the graph. Okay, so we'll just do one more. We're not going to, like I said, we won't graph this one, but so if I have something like this, y equals negative 1/3 times x plus 5 squared minus 4. Okay, so I want you to tell me what each of these different things are doing to it. So what is this? So this negative 1/3, how is that changing the shape of our parabola?
That is that one is down, upside down.
Yep, upside down.
And
what else?
Is move left.
So what else is that 1/3 doing though? So the negative is telling us it's upside down. But what about that 1/3? Let's go back up here. Remember how we said if it was like with this 2, what did that 2 do to it? And it made it skinnier.
Oh, it's skinnier.
But this time it's a number between 1 and 0. All right, 1/3 is, well, I guess I should say between 0 and 1 or negative 1 and 0. All right, it just needs to be a fraction.
How can I pronounce that? Wheat or white?
Wide, yep.
Wide.
Yep, wide. Yep. So this is meaning that it's going to be wider. Okay. So it's just going out faster than it's going up is what's happening there. Okay, and then what about this, that x plus 5 part? What is that doing to it?
The 5 is moving left.
Yep, move left 5 places. And then what is that?
That 4
that -4 doing?
is looking down.
Yep, it's moving down 4 places.
In that case, the 1/3 is between 0 and 1, right?
Yeah, so it's just like a fraction. So I kind of re-put this on here. So it's, a number that's between 0 and 1, or a number that's between -1 and 0. So if it's a fraction, does that make sense?
Yes.
Then that's what's making it wide, is if it's a fraction, not a whole number. Okay.
And now we need to do the vertex. Right?
Yep, so what would the vertex be?
The vertex is -5, -4.
Yep, perfect. Okay, so sometimes it will just ask you this, you won't have to graph it, and then other times you'll need to graph it. Okay.
And now we need to do more points, right?
Yeah, if it asked you to graph it, then you would, but I'm not going to graph this one just so we have time to get to some of the other stuff. But you would do the same thing that we did up here. What would be good numbers to pick, I guess? I'll ask you that. We don't have to do the whole thing, but what would be good x values to pick? That would be a good thing to talk about. So like, why did I pick 0 and 2 on here? And why did I pick 1 and 3? Do you remember what I said? Like how I came up with those numbers?
Because it's the vertex.
Yeah, so we said, so we have -5, right, is our x value. And so we want to pick numbers that are around that. So one that's smaller than it, and then one that's bigger than it are usually good numbers to pick.
And also I can take the y value, like take the -4 on the other side. Oh, is there?
Yeah, so we already found this one, right? But now you'd want to put -6 in place of your x here to figure out what y is, and then put -4 in place of your x value to figure out what the y is for that.
Okay.
Okay. And then you just graph those points on your grid. Okay, but yeah, that's the way to kind of think about what you would want to do. Okay, let's see. There's kind of one other type of problem that you need to know how to do for the homework. So let's look at one like this. So it will say something like this: write a quadratic function or equation, put a quadratic equation with a vertex of -2, -4, and then through the point 1, 9. Okay. So remember that when we're looking at that, so I'm going to write it down again, that equation that we talked about at the very beginning is y equals And I'm going to leave the a part off because we don't always need it and it's not given. Well, actually, let's put it in. Y equals a times x minus h squared plus k. All right, so this is that vertex form. And our h and our k is the vertex. So I'm going to kind of write some of these things in here. So that h and that k are the points that make up that vertex, right? Like we've talked about on these. And then we know that this is a point, and ordered pairs are just made up of just x's and y's. Let's see, maybe I'll put it in as purple or something. So so this is my x and this is my y. And so that same x and y that are here is what I need to understand. That's where those x and y's go. So I can fill in everything here that I know, and then it's just that a there that I don't know, and that's what I need to find. So when it's telling me to write in a quadratic equation, I'm going to put the stuff into this formula that they're giving me, and then there will be one piece that it's usually going to be the a that it doesn't tell me that I'll have to solve for to figure out what that is. Okay, because remember our x and y, there's a lot of different x's and y's, right, that we could come up with. I mean, on these, like we find 3 different x's and y. This is just one point that is on that graph, but there's lots of different points that those x's and y's could be. So let's go ahead and put things in here. So in place of the y, I'm going to put 9. And then, let's see, and that equals a. And I'm going to put a in blue here because that's the part that we're going to be solving for. All right. And then my x, what is my x value there?
1.
1. Okay, and then minus h. What's my h?
Minus 2.
So I'm going to do minus, and I'm going to write it this way, like so I'm doing minus a negative 2. All right.
Okay.
And then squared. And then plus, what's my k?
Minus 4.
Yep. So minus 4 there. All right, and now we just kind of need to simplify things up so we can solve for a. Okay, so are you clear on where I put all those numbers and why I put them where I did?
Yes.
Okay. All right, so let's go ahead and kind of use order of operations to do this a little bit more. So here, when I'm doing minus a negative, that's really adding, right? So 1 plus 2 is 3. And then I have the squared. And then plus a negative 4 is just minus 4. So I've got 9 equals, well, a times 3 squared. Well, 3 squared is 9. So I've got 9a and then minus 4. Okay, so I just kind of have that simplified up there, but now I'm trying to solve for a. So what do I need to do to get a by itself? How can I isolate a?
We need to move the minus 4 to the other side.
Yep. So let's add 4 to both sides. So 9 plus 4
equals 9a.
Is 13. 9 plus 4.
Yes.
13. Okay. So, yep. So 13 equals 9a. And then what's left to do?
Divide it in the other side by 9.
Yep, divide both sides by 9. So I get A equals 13/9. Okay, now I'm not done. I figured out what this A is here, but notice it's telling me the instructions are I want to write an equation. So I pretty much go back to this original equation here, and now I'm going to put in, I now found out what A equals, so I need to put that in place of my A here. So maybe I'll just write it in blue just to make sure it's clear. That's what I found was what goes in here. Okay, now remember when I'm writing an equation, I don't know what X and Y are because they could be a number of different things. So I keep X and Y as part of my equation. So I'll have Y equals, and then in place of that A, I'm going to put 13/9, and then parenthesis, remember X is, I need to keep as part of my equation. So I got X, but then I need to put in my vertex. So I'm going to put, that's going to be minus a -2 squared, and then -4. And then you can just, kind of, you could simplify this up so it says X plus 2 because minusing a negative is really plus. So Y equals 13/9 times X plus 2 squared minus 4. And then that would be your answer. That's how you would leave it. What questions do you have there? Oh, it's a little bit weird, but you're just putting into that formula the things that you know. Solve it for A. Once you figure out what A is, then we're going to put that back into the formula where it goes.
We solve it for A because it's the only one they missing, right?
Yep, because everything else we had numbers for. So that's the only thing, that's why we solve for A. It's exactly right.
Okay.
Okay. All right, so let's go to, let's look at a few things then on 8.7 also, okay? And maybe, I think I might just